So what does this imply about future models? You mentioned that the Llama 3 8B is better than the Llama 2 70B,
No,
right?
no, it's nearly as good.
Okay.
I don't want to overstate.
But does that mean like the
in
Llama
the same
4
order of magnitude?
Does that mean like the Llama 4 70B will be as good as the Llama 3 4 or 5B? Like,
I mean,
what is the future of this look
This
like?
is one of the great questions,
Yeah.
right? That I think no one knows. Is basically, you know, it's one of the trickiest things in the world to plan around is when you have an exponential curve, how long does it keep going for?
Yeah.
And I think it's likely enough that it will keep going, that it is worth investing the tens or 100 billion plus in building the infrastructure to assume that if that kind of keeps going, you're going to get some really amazing things that are just going to make amazing products. But I don't think anyone in the industry can really tell you that it will continue scaling at that rate for sure, right? In general, in history, you hit bottlenecks at certain points. And now there's so much energy on this that maybe those bottlenecks get knocked over pretty quickly. But I don't know. I think that's an interesting question.
What does the world look like where there aren't these bottlenecks? Suppose like progress just continues at this pace, which seems like plausible. Like zooming out,
well,
forgetting about like llamas.
There are going to be different bottlenecks.
Right. So if not training, then oh yeah, go ahead.
Well, I think at some point, over the last few years, I think there's this issue of GPU production.
Yeah.
Right. So even companies that had the models, that had the money to pay for the GPUs, couldn't necessarily get as many as they wanted because there were all these supply constraints.
Yeah.
Now I think that's sort of getting less. So now I think you're seeing a bunch of companies think about, wow, we should just like really invest a lot of money in building out these things. And I think that will go for some period of time. I think there is a capital question of like, okay, at what point does it stop being worth it to put the capital in? But I actually think before we hit that, you're going to run into energy constraints, right? Because I don't think anyone's built a gigawatt single training cluster yet, right? And then you run into these things that just end up being slower in the world. Like getting energy permitted is like a very heavily regulated government function, right? So you're going from, on the one hand, software, which is somewhat regulated. I'd argue that it is more regulated than I think a lot of people in the tech community feel. Although it's obviously different. If you're starting a small company, maybe you feel that less. If you're a big company, we just interact with people. Different governments and regulators are, we have kind of lots of rules or that we need to kind of follow and make sure we do a good job with around the world. But I think that there's no doubt that like energy, and if you're talking about building large new power plants or large build outs and then building transmission lines that cross other private or public land, that is just a heavily regulated thing. So you're talking about many years of lead time. So if we wanted to stand up just some like massive facility to power that, I think that's a very long-term project, right? And so I don't know. I think I think people will do it. But I don't think that this is like something that can be quite as magical as just like, okay, you get a level of AI and you get a bunch of capital and you put it in, and then like all of a sudden the models are just gonna kind of like I think you do hit different bottlenecks along the way.